Okay, so this is a quick video to talk about a type of screening experiment that we like to do with enzyme-based sensors. So for example, if you look at our glucose sensor, we have this kind of screening experiment where we show signal as a function of time. The signal we're showing is current versus time, and the way we kind of obtain this kind of data is to allow the current to start high. It comes to a baseline, so that's in a sort of 0 millimolar concentration, and then in this example it's a glucose sensor. We add 5 millimolar, get a new plateau, 10 millimolar, get a new plateau, 15 millimolar, get a new plateau, and then 20 millimolar and get a new plateau. So what I'm going to say in the next part of this is we want to do this in a consistent way. So every sort of block or phase of this experiment, we're going to do it for 500 seconds. So this is what we're kind of aiming for or towards, but now let's talk about the actual data itself. So what I'm going to do now is I'm going to cut into Djuli. Djuli is a proprietary cloud database system that Zimmer Peacock has. It's for the storage, analysis and sharing of data. So what I'm going to do first of all is store my data into Djuli. So I will just go down and grab some data. Alright, so I've grabbed the data. It's uploading the data now into Djuli, and what I'll do shortly then is essentially process it. So Djuli is pretty useful because in many programs and companies you don't always know exactly where the data is. Well, at least with ZP and with our collaborators we know where the data is. So I've uploaded the data now. Now I'll go to properties. This is an amperometric experiment, so I've chosen amperometry here, and I want the raw data. I want to fit the raw data. I want to show some statistics on the raw data, and I will configure concentrations. So what I want to say is the way we at ZP want to do this is we want to do the 500 sort of second window. So what I mean by that is what I'm going to do is I'll delete all of this. And now what I'll do is, sorry, I should have done that. I'll add, it's put in a 0 here. So at what I'm going to do is I'm going to say something like 350 seconds. The concentration was, in this case, 0. Then I'll add in, so what I'm doing is I'm telling the database what the concentration was at any certain time point in the experiment. And from there it can then sort of calculate my values like limit detection on, I think, limit of blank, but let's have a quick look. 650, I'll say that's 5. I'll add another one in here. I'm just looking at the thing here. I'll put 1250, and at 1250 the concentration was probably about 10ish, and then I will add a fourth one in here, and if I look at the, I'll put 750 there, and then that I'll put that 15 there. Right, so what we've done is we've uploaded the data. You saw me upload the 3 files. I told the database this was amperometry, which is what it's done. I've now told it, you know, that because these experiments were done in a consistent manner, we've uploaded several experiments, but I've told them all that you know that because we did it in a consistent way, that, you know, the first part of this experiment was done in 500 seconds, then the next part was another 500 seconds. So the operator's been very consistent. So now we can actually just tell the database that for all the time at time 350 all the experiments were at 0 millimolar, at the time 650 all the experiments were at 5 millimolar, at the time 1250 all the experiments were at 10 millimolar, and at the time 1750 seconds they were all at 15. So I go done there. I think I'm more or less done, and now it's doing the processing of the data, and we'll have a quick look at what we got here. Okay, so what we have going on now is there's my raw data. So you can always have your raw data. These are the sort of concentration and time points that I just manually put in, and therefore from there the database can now kind of calculate essentially, you know, the linear fit, sort of y is equal to mx plus c type calculation. We can see the distribution in our data. You know, we can see that we've got a fairly tight distribution around about 0, but there's quite a spread when we get out to 15. And we have some other things like limit of quantification, limit of detection, standard deviations, and means. You know, that's all sort of produced here. It's not really part of what I want to show in this video, but I do show it in another video where you can export the data. Now, the reason for having this video is I want to make sure that when we're doing sort of enzyme type sensor screening experiments, if I could describe it as that, is that we do them in a consistent manner. We start off with something like 0 concentration for 500 seconds, then the next concentration for 500 seconds, then the next concentration for 500 seconds, and then the next concentration for 500 seconds, so that we can then do this kind of batch analysis on the data, and it will really speed up the processing time. Okay, so Djuli's pretty powerful. It's for the uploading, analyzing, and sharing of data, and you can obviously produce reports, etc. from that. Okay, thanks very much.